Hello, this is Team 18, and for our final project, we were inspired by the antlion larva, a small ambush predator that when it captures prey, it remains still while holding it, and reacts defensively when stirred. We translated these biological ideas into our LEGO Spike Prime robot, called the Mechanical Antlion, designed to interact with ping pong balls in a way that resembles a cautious predatory organism using the simple tool. When it comes to neurorobotic design principles, we first applied embodiment and efficiency through cheap design. When designing the robot, its behaviors depend heavily on the placement of its wheels and sensors. To have the robot interact with either the white or red balls, it has to differentiate between the two through the color sensor as shown here. Then, using cheap design, we created a cheap wheel-based capture mechanism, replacing a more complicated grabbing device. Then with the distance sensor, it faces down towards the slot where the ball gets retrieved in order to verify that the ball is secured in place. For the more complicated neurorobotic design principles, we use exploration versus exploitation, learning and memory, as well as stress versus calm. In its exploring state, it moves through the environment in sweeping turns and forward bursts, searching for possible targets. When it encounters a white ball, it decides probabilistically whether to attempt capture based on what it has learned from previous trials. If the ball is successfully secured, the robot shifts from exploration to exploitation by holding the ball and no longer searching for new objects. In its calm state, the robot either explores or passively holds the white ball. In its stress state, it is triggered by a double tap detected by the motion sensor, which immediately switches to a defensive action and throws the held white ball away before returning to exploration. This gives the robot a lifelike transition between calm possession and rapid defense. All of this is done from learning and memory through the probabilistic updates and behavior. The robot gradually learns that white balls are useful and worth capturing, while red balls are undesirable and should be avoided. These learned preferences are updated over time using reward values and softmax-based decision process, allowing the robot to gradually build confidence towards white balls and fear towards red balls, instead of behaving in a fully fixed way from the beginning. This is the end of our presentation. Thank you.